Today's webinar seminar is regarding the IDEA Statica Connection application, and the topic of it is fast and reliable design of steel connections. So let me introduce myself. I'm consultant at Intelligent Beam Solution in Lithuania, Robertas Zavalis, and today I'm going to be a presenter for this seminar. So let's first of all, let's talk about the agenda of our seminar. First of all, we're just simply gonna talk about what is IDEA Statica, what is IDEA Statica Connection, and what is behind IDEA Statica Connection. And then we're gonna perform a short example. So IDEA Statica, this is a company with a great experience, with a long experience producing, developing finite element products for construction designers. And the main, let's say, it has two main products which are related with the steel and concrete. For concrete products, IDEA Statica has these products as member, beam, RCS, and detail. But of course, today's topic is about steel connection. So let's leave the concrete part for the future. Then for the steel, we have this member application, which is a very powerful, innovative application, which lets you, let's say in a short way, if there is restrictions according to Eurocode, the IDEA Statica steel member application can find you a way to design the constructions. And IDEA Steel Connection is our topic today, and we're gonna talk mostly about it. So what is IDEA Statica Connection application? In a short word, it can be said that this application gives you a possibility to design steel connections according to Eurocode in a fast and reliable manner. And what is behind this IDEA Statica Connection? IDEA Statica Connection joins some methodologies in one place. In Eurocode 3, in steel Eurocode, there is a methodology how to calculate steel connections. And IDEA Statica uses this component method, and together with the finite element method and innovative models for bolts and welds, combines everything together in one new method, so-called CBFEM. This CBFEM method can be translated as component-based finite element method, so it's quite easy to remember. And the main idea of it that all the stresses in the plates of the joint components as steel profiles, welds, plates, and so on, and of course the internal forces in bolts are calculated according to finite element method, using the finite element method. But later on, the design part, the verification part is done using component methodology used in Eurocode. So for example, the bolts, welds, those will be verified according to Eurocode. What IDEA Statica Connection can provide for us? Besides overall check whether the joint satisfies the design criteria. It can give us stress strain analysis, distribution of stresses and strain. Then we can much clearer see what's happening with the joint and let's say make changes and better design later on. Idea Statica can calculate the stiffness of the joint. For those who are familiar with the Eurocode, there is a huge methodology description which lets you to calculate stiffness of the joint also. But for example, if you write a formulas, a algorithm for some kind of joint, later on, if you would like to make some kind of change, you will have to rewrite all the methodology. So Idea Statica lets you to calculate, to investigate the joint by changing its geometry without in a fast manner within the minutes. So stiffness calculation lets us to understand how the joint behaves, whether it is a fixed joint or it is a hinged joint or it is somewhere in between. Yes, so later on it can be used in the global software analysis to calculate the internal forces in our construction. Besides that, Idea Statica lets us to calculate the strength of the joints in seismic regions. And let's say one of the favorite of mine is that Idea Statica lets us to calculate the buckling, to perform buckling analysis, with which we can to define whether components of the joint is strong enough to withstand the internal forces which are acting on it. Idea Statica lets us to design joint resistance, so the maximum capacity of the which can handle the joint. Yeah, so it's very important when we want to design rational constructions. When we, for example, design a beam and then we design a connection, beam and column connection, for not doing the overkill in the joint, or let's say it helps us to design joint not weaker than the whole beam, for example. This was the main idea what I wanted to say. Later on, after the example, I will be glad to to have questions, and we can discuss later on. So now I will switch to Idea Statica application. Okay, so with the Idea Statica connection, we have this. In Idea Statica, we have these main applications. For the concrete, we have this, as I showed previously, and for steel, here we have some applications. Now we are connecting to connection application. And Idea Statica, first of all, lets you to, let's say, for not to create the model from very beginning, from scratch, you might use some predefined templates. So as you see, there is plenty of templates. I tried previously to count how much possible templates there is, but something above 300. So so definitely it's possible to find something suitable for you. For example, as beam and column connection,
beam and beam connection, trusses, some templates for connections with the concrete foundation, and some, let's say, different type of connections. Yes, of course there are possibility, for example, to start from very beginning, from scratch, from white paper, let's say. But for today, to keep it short, we will start with some kind of template. I will choose this column beam template, and I will choose this simple, let's say, geometry type. And then let's take this design template for here. Here we have to define the steel grade. For example, we can define steel S355. Talking about materials, idea Statica Connection for the analysis uses nonlinear type materials. So later on we have possibility to change it, to adopt it, and to adopt it for your needs. Yes, so let's create the project. While the project is creating, I really would like to mention that Idea Statica has very powerful tools connecting Idea Statica Connection to CAD softwares and other CAE softwares. I mean, that kind of softwares as Global FM, SIA, Robot, and STAD, and so on, and CAD softwares as Tekla Structures and Revit and other products. There are possibility to model the joint, for example, in Tekla Structures, upload it into Idea Statica, and then, for example, create the model of the building in your global analysis software which you are using. For example, as I said, Global RFM, and then after the calculation, export the internal forces into the created geometry of the connection, for example, from Tekla Structures. So it's possible to incorporate all, let's say, CAD software, calculation software, and Idea Statica into one work, let's say, into one job. So our model is created, and as you see here, we have all the components for we can change parameters for all components. For example, here we have this beam. We can change its section. Of course, as I said, we can create any as many beams as we need. So Idea Statica Connection doesn't have any limitations for connection geometry. So it is various modifications can be done. Let's say I'm gonna take this IP slightly bigger cross section here, and as you see, I changed this cross section, and since I use the template, yeah, this joint adopt to the right cross section which I modified. Yes, so it's when we are creating geometry from template and, for example, adopt it, all the components, they are parameterized and can, let's say, adopt to the changes that we make. Yes. Also, later on, we can check after completing the joint, let's say, Oh, sorry, I forgot to talk about the. As I said, we can add members as much as we need, but all those connections are created here in operation option, and here we have many tools to create any shape as you want. For example, I need to create an opening in some kind of element, and here the opening is created. Okay, maybe not, this is not the element I wanted, but I can change it. You see, this is our new operation created. I choose it, and I choose on which element I want to put it. So for example, here this beam, it has its name, and it is beam's wall. Yeah, and so I stand on this operation and I choose this beam web 1. Yeah, and so it this whole starts to be related to that web. And of course we can make we can do various for example shapes of that opening, and for example let's slightly modify it. Oh, sorry, it's not the right keyboard. Okay, let's slightly modify it, and then the position if it's needed, for example if the eccentricity is needed also, maybe some reinforcement is needed, we can add it here, and so on. As you see, we can modify it as we want. So another besides the operations, another very important topic is load effects. Yes, because loads are transferred from our global analysis system, and it should be transferred in the right way. So for example, here we see this not 3D model. Yes, it looks very nice, but in global analysis system we usually have these 1D elements, and they are joining in one point. Yes, the same idea is here too. For example, if I will turn this wireframe model, I will see that my beam is represented as a 1D element, and here column is represented as a 1D element too, and they are joining together in one node. So I can decide what kind of well, and the forces are located on that current node. Of course I can choose the model where the forces can be located. Yes, for example, if since this connection is stiff, yes, so I might say that okay, the internal forces, not the internal forces, but reactions should be in the node. Yes, reactions, I mean about this cut of the beam. But for example, if my joint would be a simple joint as a hinged, I might use that the forces should be in the bolts section. Yeah. So or I can make a position in any where I need to. So for example, this beam, what we have here, if we're gonna check how it looks like, yes, so we see this this change of bending moment. So the start of bending moment is 100 here, 100 kilonewton meters, so it's in the node, and on this beam 20 kilonewton shear force is acting. So the bending moment, it's slightly decreasing because of this shear force. So this part of the section which we have here is mainly, like, let's say it represents the action, how the internal forces in the beam is acting. so we can adjust it as according to our needs. So after completing the joint geometry and after adding internal forces, of course we have to check the unbalanced force, that all the forces, those unbalanced forces let us know whether we added the forces in the right way. Yeah, are the directions is correct. So after the finishing everything, we can start the calculation. Yes, so I will run the calculation. The calculation is performed in incremental method, because here in idea Statica Connection, steel is used as a non-linear material. Yes, with a possibility to reach plasticity. Yeah, and well, we can even check here if we see here that all 100% of load is added, so everything looks okay in my design right now. And now at the first step we get this like a traffic light option, where green color shows that, well, there's everything with the design, and the gray color shows that, well, this is that here stresses is much lower than the maximum possible stresses. And here also we see that there is this let's say utilization rate of bolts, welds. And to check our design more carefully, we can check it one by one. I mean, for example, we can check stresses and we can check here stresses in the model. Yeah, here's the first of all, this is the regions where the sum of plastic strains appear, so we can check where those strains are, and the shape of the appearance. For example, this plate here, we can see it in detailed way. We see that somewhere in the top there is some kind of stress concentration, so plasticity appears. We can also check the equivalent stresses. Since in the wall some plasticity appears, so here in this region we are near the maximum of the stresses. Also we can check the plastic strains, where those appear. Here, for example, here in this plate, you see that, yeah, because it's at the bending, this is the most compressed part, I guess. And besides that, we can check the forces in bolts. Yes, you see those. Here in picture we can see tension forces, and as you see, since our model is bent in this plane, yeah, we can see the deformed shape. We will see how it is bent, and with the mesh it is more clear then. Yeah, so this is how it is bent. And of course the forces in those top bolts are much higher than in those lower bolts. Yeah, but still there is some action there because of the how it is called in Eurocode, the preying forces appear in the bolts, not because of the tension but because of the deformation of the plates. Additional forces appear. Yeah? So here, as we see here, we can check the status of the plates, and of course we can check the status of the bolts. For example, here I would like to know, for example, this bolt. Okay, this is the button. This bolt is number 4. This is the right bolt, B4, and we see here the, what kind of tension force appear in the bolt, what kind of shear force appears in the bolt, and its resistance and utilization level according to various checks. If we want to see more detailed view how those checks are done, so we can press this plus button, and here we can get all the Eurocode formulas to see how the check was performed. For example, here the tension resistance check, then it's a punching resistance check of the plate, then shear resistance of the bolt, and bearing resistance check, and of course how the utilization levels, utilization ratios were calculated. Sorry, again this interruption of connection of internet, I guess, failed. Yeah, we have this joint, weld. Yes, for example, this weld on this let's say plate and beam web connection. Yes, here we see its location, and we can see how the stresses distributes along the whole weld, and of course we can when we see the real situation, we always can make some kind of changes. Yes, so also here weld is, oh sorry, but some kind of, there is no value some way. Let's try to reload it. Somehow, well, the check was not performed. I don't sorry, I think that I have to rerun the calculation or something like that. Before I rerun the calculation, I would like to say that for example, what I mentioned before, that Idea Statica gives us a possibility to run the buckling analysis of the components. So, for example, this plate is highly under compression. Yes, we see even the there is this the stress concentration in this situation. So, for us to see that this element will not buckle, for example, it is not so easy to check with by hand, but Idea Statica, for Idea Statica, it's simply one click of a button to see the buckling mode of all joint, and then we can decide whether the buckling whether our joint is strong enough or not. So I ran the calculation again with the now with the buckling calculation, so we will be able to check the buckling modes for this joint too. Yeah, so it's double calculation. I guess since I have to translate the video, so it takes much more time to calculate it. Okay, the results are loading, buckling, and we see this buckling shapes. We can even present those in the screen. Yeah, it's simply let's say the first buckling shape. Maybe it's not so yeah, this is the more realistic maybe. So it's as you see, it's the components for our are not failing. So for the joint it's okay, but as we see for the column, it's the weak spot here as at the top too. So maybe it would be wise, for example, to add a couple more stiffeners here and let's say get rid of this buckling mode shape. Okay, so I will try to load another geometry. Just I would like to show that definitely the welds are calculated. It's because I guess I had to change the computer. So okay, so let's try to check it in a fast manner. Yeah, it's very visible right now since, as I said previously, the iterations are done. So software first of all gives puts all 100% load. Then if no convergence appear, then it decrease the load and applies load incrementally until 100%. If software will not be able to reach 100%, it definitely give us some kind of warning or error that not all the load is added, so it's not possible to miss it. Yeah, I guess I choose the wrong type of steel. Maybe this template was done for different. Yeah, the welds, yeah, 100%, so it's above. Okay, let's check the welds, how it looks like. This is the only thing that I didn't show yet. Yeah, so now it's okay. For example, as the same way as for the bolts, you see we have all the information about the welds. As I said, here we have this the way how the stresses appear in the weld, and if we press the plus button, we can check how all those let's say utilization levels was calculated and how the stresses are verified according to Eurocode. Again, after all calculations, if everything is okay with your joint, you can make a report. This report can be in a very detailed manner if needed, or it can be, let's say, very simple. It depends upon how well upon your needs, let's say. For example, here we have this all the general view of the joint, and here, as you saw, that welds reached 100% and above, so it says that it's not okay. It gives you general pictures at the beginning, and yeah, if for example, if drawings are needed, if you would like to have more detailed, for example, more detailed report with theoretical background description, it's also possible to do that. Also, all the report might be exported into PDF, DVG, or DXF format. Why DXF? It's more CAD format, let's say, but it is very comfortable, very nice to have the sketches of the joint which we have to draw. So even we could share with our colleagues those sketches. For example, one colleague makes the calculation, and then he can share the sketches of the joint with the other colleague who's gonna draw the joint. So it is very comfortable to share that information. It should give us it right now. Yes. Oh, the sketches. Yeah, all the calculations are, since I asked, very precise report. So, and here are those sketches. Okay, we didn't had let's say many plates or something, but yeah, at least we have it here, so we can export this plate and draw it. For example, if some kind of change is done for the plate, for example, I can edit it. Let's say I would like to add a hole in this plate, where circle, corner 0, okay, it's not a 0, let's make it something like 50 and 50. Yeah, and circle, let it be something else of 50. Yeah, it's just for fun. Let's say I just wanted to show you this, for example, what kind of sketch Idea Statica can perform. So this kind of sketch Idea Statica can generate, and this kind of sketch we can export in DXF and then use for the drawings. So have a good evening, and we hope we're gonna meet next time, and I hope without any technical issues anymore.